today we will see the optical isomerism. Optical isomerism. What is meant by optical isomerism? The compound having same molecular formula. Compound having same molecular formula, but different behavior towards plane polarized light is called optical isomerism. It's called optical isomerism. So, what is like optical isomerism? The compound which having the same molecular formula but different behavior towards the plane polar light is called as optical isomerism. Now, what is in like plane polarized light? Plane polarized light. That is PPL. Now, when ordinary light passed through a Nicol prism, ordinary light passed through a Nicol prism, then this transmitted light is vibrate in only one plane. Transmitted light vibrate in only one plane. Then this light transmitted light vibrate in only one plane. Then this light is called as plane polarized light. Now this is a ordinary light. This is Nicol prism. So what is the plane light? Where ordinary light passed through a Nicol prism, and transmitted light vibrate in only one plane is called plane polarized light. It's called the plane polarized light. Now, next definition is optical activity. Optical activity. When compound having tendency to rotate, compound having tendency to rotate plane polar light to a particular direction, then compound is called optically active compound. Optically active compound, and phenomena is called optical activity. Phenomena is called the optical activity. Right? Particular direction, that is a clockwise or anti-clockwise direction, then this compound is called the optical active compound and the phenomenon is called the optical activity. Now the next important definition is dextrorotatory. Dextrorotatory. Dextrorotatory compound. If compound rotate plane polar light to clockwise direction, then this compound is called dextrorotatory. It is denoted by small d or plus sign. It is denoted by small d or plus sign. The compound which rotates the plane polar to the clockwise direction is called as a dextrorotatory. Then the next definition is leorotatory. Leorotatory. Exactly opposite definition. If compound rotates the plane polar light, if compound rotates plane polar light to anti-clockwise direction, then this compound is called leorotatory and it is denoted by small l or negative sign. Small l or. Then the next definition is most important definition for the optical isomerism, that is chiral carbon or asymmetric carbon. A chiral carbon or asymmetric carbon. A carbon atom which is bonded to four different atoms or groups. Four different atoms or groups at is called chiral carbon, is called chiral carbon or asymmetric carbon atom. Asymmetric carbon atom. A carbon atom which is bonded to four different atoms or group is called the chiral carbon. For example, now this carbon atom is attached to the four different atoms or group of atoms. It's called the asymmetric carbon atom or chiral atom. Now this carbon atom is attached to four different atom or group of atom. Therefore, it is called the asymmetric carbon atom. Chiral carbon or asymmetric carbon atom. Okay. Now, the next definition is chiral molecule. Now, what is meant by chiral molecule? If compound having two chiral carbon atoms and no symmetry, then that compound is called as the chiral molecule. Chiral molecule. If compound having two chiral carbons and no symmetry, and this compound is called chiral molecule. Is called chiral molecule. For example, now these 2,3 dihydroxybutane dioxide acid. Now in this case, this first compound having a plane of symmetry, therefore this molecule is a chiral molecule. Is having a plane of symmetry, therefore this molecule is a chiral molecule, and therefore this is optically inactive. Now in this example there are two asymmetric carbon atoms, but it having a plane of symmetry, therefore this molecule is called as a chiral molecule. It is optically. But in this example there are two asymmetric carbon atoms, but this molecule does not having any symmetry, and therefore this is called a chiral molecule, and it is optically active compound. It is optically active compound. So this is the chiasm molecule. Now next definition is enantiomers. Enantiomers, stereoisomers which are mirror images of one another. Stereoisomers which are mirror images of each other and non-superimposable and non-superimposable, then such stereoisomers are called the enantiomers. The stereoisomers which are mirror images of each other and non-superimposable of each other are called enantiomers. For example, lactic acid, this COH, this CH3, this OH, and this H. This is the mirror, and this is the mirror image. That is C, this H, OH, and this is. So these two are the enantiomers of each other. These are the mirror image of each other, and these are the non-superimposable. Therefore, these are called the enantiomers. Now, the next definition is distereoisomers. Next definition is distereoisomers. Image, the stereoisomers which are not mirror images of each other. Stereoisomers which are not mirror images, of each other are called distereoisomers. For example, 2,3 dichlorobutane. Now the CH3, Cl, this Cl, and this CH3. Now the CH3, C, this C. Now in these four structures, first, second, third, and this is the fourth structure. There are the four structures. Now see here, the structure first is a mirror image of structure second. Structure first and second are mirror images of each other. Structure third and fourth are the mirror images of each other. Okay. So structure first, second, and third and fourth. These are the first and second are the mirror image of each other, third and fourth are the mirror image of. So these mirror images of each other are called the enantiomers. Enantiomers. So first, second, third and fourth are called the enantiomers. Now comparing this structure first with this third. Now this structure first is not mirror image of third. Similarly, structure first is not mirror image of fourth. So first and third, first and fourth, these are the not mirror image of each other. Similarly, structure second compared with this third, the second is not mirror image of third. Similarly, second is not a mirror image of fourth. So structure second is not mirror image of third, and second is not mirror image of fourth. So these structures are not mirror. First and third, first and fourth, second and third, and second and fourth are not mirror images of each other. Therefore, these are called distereoisomers. Distereoisomers. So in this example, there are two asymmetric carbon atoms. 4 isomers are formed. Out of these 4, there 4 are di and 2 are the enantiomers. So this is the distereoisomers. Now next definition is meso compounds. Next definition is meso compounds. Meso compounds. Compounds having at least two chiral carbons, two chiral carbon atoms, compounds having two chiral carbon atoms, and a plane of symmetry. Compound having at least two chiral carbon atoms and a plane of symmetry is called meso compounds. For example, of the COOH, H, OH, this H, and this CO. Now this compound having a plane of symmetry, therefore this is called a meso compound. This compound having two chiral carbon atoms but having a plane of symmetry, therefore this is called the meso compound, and this is optically inactive. It is optically inactive. Due to internal compensation. So this is the meso compound. The next definition is racemic mixture. racemic mixture. It is an equimolar mixture of the X2 and LEO form of structures. It is an equimolar mixture of dextro and LEO form isomers. It is an equimolar mixture of dextro and LEO form isomers or enantiomers. It's called racemic mixture. It's called racemic mixture. It is optically inactive. It is optically inactive due to optically inactive due to external compensation. It is denoted by small d and L or plus or minus sign. It is denoted by small d, L or plus or minus sign. So this is the racemic mixture. So these are the most important definitions in optical isomerism. Okay, thanks.